Hi, this is Lawrence O'Neill. I'm attending NC State, and I'm currently in the class MAE 535 Design of Electrical and Mechanical Systems with Dr. Buckner. Today I'm here to talk to you about Faraday's Law. So this is the equation for Faraday's Law, and essentially what this means is the net induced electric field along a closed contour, L, equals the time rate of change of the magnetic flux enclosed by that contour. Now what does that mean? I'm going to show you. First off, I have just a simple wire. It's a wire with two connectors, and then I have a voltmeter back here, and then of course I have my handy dandy magnet with my handy dandy tool. It's just a drill bit. As you change the magnetic flux, you create an electric field, and that creates a voltage. So all we have to do is change the magnetic flux. So first I'm going to do is just show you as you move the magnet, you change the magnetic flux and you'll create a voltage in this wire. So all I'm doing is I'm just kind of waving and crossing the lines of flux. And you can see that over there on my handy dandy voltmeter, I'm creating a voltage. So now what I've got this time is I've got some magnet wire. It's like 300 feet of 30 gauge magnet wire, and it's wrapped about 500 times on here. I used a drill to spool it up on here. I've got one end of the magnet wire going to my positive or my negative connection, and then one end kind of feeding down here. What I'm going to do is basically I'm going to put this magnet through this coil, and you're going to see over here on my little LED, you're going to see it light up. Let me get my little voltmeter connected, and you're going to also see the voltmeter jump around, but it doesn't read, because it's happening so quickly it won't update fast enough, but you can see how it's changing. But essentially I'm putting the magnet through the coil, and you can notice, so basically I'm changing the magnetic flux through this little contour, and it's inducing a voltage over there. So the final demonstration I wanted to do is basically I want to use my arm, my muscle, to power my phone for me. So what I did is I actually bought this DC motor. It spins pretty fast, that actually spins these gears, and then this shaft actually spins at a way slower speed because it's geared down to spin slower. See, the gears start out big and get smaller, smaller, smaller. So I'm going to spin this kind of like manual speed, and then it's going to cause this motor to spin really fast. And what's inside of the motor is basically there's an armature with a bunch of coiled wires, and right outside of the armature there's a magnet which creates a magnetic field. So as you spin the armature really fast, you're changing the magnetic flux inside of this motor, and you feed out actually a voltage. Got my little gearbox. Oh, it popped off, but here's my gearbox. I got my positive and my negative hooked up, and then I have my shaft on the back where I'm going to attach my little handy dandy wrench to it. And you can see here I actually have a car adapter where I have the positive terminal here, I have the positive terminal, negative terminal, and I'm also monitoring the voltage back to the voltmeter. And I actually included a capacitor in here, right here. It's kind of hard to see, but I included a capacitor just to make sure I didn't have any huge voltage spikes, so I didn't like burn up my phone. But here you go. I'll give it a whirl and see what you guys think. And so you can notice the voltage and my phone light up. All right. And it's because I'm not giving it a steady voltage. It glitches out, but it's charging right now. You can see over here I was getting between 6 and 10 volts, I think, while I was looking. But like I was saying, this is just Faraday's law applied. You spin a bunch of coils in here, or inside of some magnets. You change the magnetic flux at a really high rate because it's spinning so fast, and so you can create a really high voltage, and you can actually use it to charge your phone. Well, I hope you enjoyed Faraday's law.